This video is designed to help first-year pupils studying physics in using the equations you meet in the first-year physics course. Let's look at Unit 1, Forces. Well, the equation that you meet in forces is the weight equation, W equals mg, and this equation will always be given to you. It will usually be printed on the front cover of the test. Okay. Now you should know what each of these quantities stands for. So W is the weight of the body, which is in newtons. Weight is a force, the force with which a body is pulled downwards towards the planet in newtons. M, of course, is the mass of the body. That's the amount of matter in the body, and it's measured in kilograms. And G is called the gravitational field strength of the planet, and it's measured in newtons per kilogram. The gravitational field strength is basically the force with which the planet pulls down a 1 kilogram mass, and it's different on each planet. Whenever you're doing problems, you'll always be told, if you need it, the gravitational field strength required. So for example, let me show you a few here. I'll just make up a little table. And you'll always get a table like this in tests and exams. So for example, if you were on Earth, this is in newtons per kilogram, of course. Every kilogram on Earth is pulled down by a force of 10 newtons, so we say that the gravitational field strength on Earth is 10 newtons per kilogram. On Mars, on the other hand, if you were to go to Mars, each kilogram is only pulled down by a force of 3.7 newtons for that kilogram. So the gravitational field strength on Mars is only 3.7 newtons for each kilogram. Okay, and there's a list of others for all the planets in the solar system. So let's do a problem. Part A. Okay, a boy has a mass of 42 kilograms on Earth. What is his mass on Mars? So there's our first problem. And the solution? Well, there's a trap in this question because the mass of a body doesn't change no matter where you are. So the solution is the boy's mass is also 42 kilograms on Mars. Okay, mass does not change wherever you are in the universe. Problem B, find the boy's weight on Earth. Right, now this is where you need to use the equation. And it's important to always list the variables So when you read the question, you know that you're trying to find the weight, because it says find the boy's weight. So you write W, and that's what you're trying to find, so you put a question mark. You're told his mass is 42 kilograms, so you write that down. Okay, so what I've done there is I've realised I'm looking for the boy's weight, so there's my W. I'm told that his mass in the question is 42 kilograms. So that's my M. And I'm also told in my question that he's on Earth. So I know that G is whatever G is on Earth. Well, I look up my table there and I see that on Earth my gravitational field strength is 10 newtons per kilogram. So that's 10. So I write that down here. 10 newtons per kilogram. So I've listed my variables. The next stage is to state the equation. And you'll get the equation from the front of the exam or the test paper. I now put in my numbers. 42 is mass times 10 for G. So basically where you see the mass symbol M, you replace that with the number 42. And where you see the G symbol, you replace that with the 10 from the question. And then you use your calculator if you need it to work out 42 times 10, although you might be able to do that in your head. 420. Now get the units correct. Weight is measured in newtons, not kilograms. That's mass, okay? So mass in kilograms, weight in newtons. So that's the answer to the boy's weight on Earth. Part C, find the boy's weight on Mars. So imagine he goes to Mars. What would his weight there be? Well, again, that's the W we're after. On Mars, we need to look up the G from our table. You don't need to memorize it. It's 3.7 newtons per kilogram on Mars. So we're going to be using that. And we already know his mass is 42 kilograms from above. So we list our variables again, W, M, and G. Well, we're trying to find his weight on Mars, so that's our unknown. Now the mass is unchanged, it's always 42 kilograms, no matter where he goes in the universe. And on Mars, G is 3.7 newtons for every kilogram. Just make sure you don't write down 10 automatically because he's not on Earth, he's on Mars. State your equation. W equals mg. 42 times 3.7. Now you will need your calculator to do that. Always have your calculator whenever you're doing any physics tests. Always have a calculator in any physics lesson as well. Times 3.7. And we get 155. It's actually 155.4 newtons, but I'm just going to round it up to 155 newtons. That's good enough for us. Okay. So that's how you do the weight calculations. Let me just draw a line there. There, good. So let us look at part 2. Now part 2 was the heat unit. There's an equation in there. Now the equation that you met in the heat unit was this one. It's that E, standing for energy, EH, H for heat, equals M, the mass of the substance, times L, which is this special heat constant that you've learned, I hope. So let's just clarify what everything means here. So that is the mass of the substance that we're talking about. Now in our course that's going to be in grams. Okay. Later on, further up the school, all your masses will be in kilograms, but to keep things a little bit simpler, we're measuring the mass in grams. EH is the amount of heat energy needed to cause the melting, and that will be in a unit called the joule, which I'm sure you've met. And this L is the special heat constant we talked about, and it has to be measured in joules per gram. So it's how many joules you need to change the state of 1 gram of the substance. Right, again, that equation will always be given to you on the front of the test or exam, and if you require it, you'll also be given the heat constant. So let's do a problem to show you how that equation works. So here it is. How much heat energy is needed to melt a 600 gram block of ice, and the change of state constant, the heat constant for ice is 334 joules per gram. What that means, of course, is that it would take 334 joules of heat energy to melt 1 gram of ice. So, solution. As always, we list all of the important variables needed for the equation, and they're all given to us in, or at least they're all mentioned in the question. So how much heat is what we're trying to find. The mass of the body is there. There's our mass, 600 grams. And the heat constant is also given to us. There it is, the change of state constant, 334 joules per gram. So you list those variables, you then state your equation. Always write the equation down. EH is m times L. So it's 600 times 334. Now you definitely need your calculator there. 600 times 334. And you get quite a big number. 200,000 400. And that's joules. Don't forget the units. One of the most common mistakes that pupils make in physics at all levels, right up to advanced higher, sometimes even, is they forget the unit. You'll always lose a mark if you don't put in the unit. So that's 200,400 joules. And that is how you do a heat equation problem. And that brings us to the end of this video on equations.